Hi students, this is AJ sir. Let's study 9th standard ICSE Math exercise 5A and 5B. Factorize by taking out the common factors. First sum. Here we can see that this bracket and this bracket is the same, so I can take it out common. Also between 2 and 6, 2 is common, so I'll write it here. So what's left over is in another pair of brackets. This bracket is left over, so I'll write it here. Minus 2 was taken out common, so 3 is left. And this bracket is gone, so this bracket is left, which will be written here. Now just open these brackets. Minus 3x, and minus into minus becomes plus. The sign changes out here. Next, 3x and minus 3x gets cancelled. 4y into 4y plus 3y is 7y, and 7y into 2 is 14y, whereas this bracket remains as it is. In the third sum, let's look for some common term or common bracket. Clearly this bracket here and this bracket here, they are common. They seem to be common, but the signs are all wrong. What can we do here? Well, if I convert this minus sign into a plus sign outside the bracket, then all the signs inside the bracket will change. This will become minus c squared, this will become plus a squared, this will become plus b squared. So now this bracket also becomes the same as this and this. So I can take that bracket out common, and whatever is left will be in another bracket, which is AB plus BC plus CA. Now in the fifth sum, we have 4 terms, and they've given us a hint, factorize by grouping method. Although in exam they won't give any such hint. But grouping is definitely possible here if we take the first 2 terms and the next 2 terms, and we try to remove something common. Here a is common, so what is left is a squared plus 1 minus, we'll have to take minus common for the next 2 terms. 3 is taken out common, so what is left here? A squared is left, and since we took out minus common, so inner sign changes to plus and 1 is left. So obviously these 2 brackets have to be the same. So the brackets again take it out common, write it once here, and the leftovers write in the second bracket a minus 3. Now a square plus 1 is actually a square plus 1 square. And what is the formula of a square plus b squared? There is no such formula. Seventh sum, again there are 4 terms. So in the first 2 terms I can take a cube as common. So what is left is a minus 2. Again minus 4 common in the next 2 terms. What is left is in the brackets a minus 2. So the brackets are same, take them out common. What is left is a cube minus 4. You want such sums to be asked in exam, isn't it? Next, in the 9th sum, we already have 2 brackets, but we can't see anything which can be taken out common. So we'll have to first open the brackets by distributive multiplication. So I get abx squared plus ab plus a square x plus b square x. We can also write it like x into a square and x into b square, the same thing. Now we have 4 terms, but if you take out ab common here and x common from here, again you will reach this step, so that won't make any sense. Rather, you'll have to rearrange the terms. Let's go for the first term and the last term, although you could try with first and the third also. So I'm taking the first term and the last term together in one group, and the middle terms here. Now what's common here? Bx is common, so what is left? Ax plus b. And what's common here? A is common, so what's left is b plus ax. Now if you notice, the brackets are actually same. Ax plus b or b plus ax is the same thing. So take out that bracket common, and what is left is bx plus a in the other bracket. Next, the 11th sum. Here we'll have to use the formula of a plus b the whole squared to expand and open the brackets. The formula for a plus b the whole squared is a squared plus b squared plus 2ab. So using that formula, I wrote a squared plus b squared plus 2ab. This whole thing is considered as a and b. So if I multiply these two together, it's actually axby, which I wrote as abxy. It looks neat. Similarly, here also, a minus b the whole square is a squared plus b squared minus 2ab, the formula. Now, plus 2ab and minus 2ab got cancelled. And I'm going to rearrange the terms, the x squared terms together and the y squared terms together, because then I can take x squared common and here I can take y squared common. The brackets are same, so take it out common, and what is left in the other bracket would be x squared plus y squared. So mark this sum as IMP. Now the 13th sum. Here I already see one bracket is existing, so let's create another bracket out here by taking it common. So here we remove minus 5 common, so what is left is 2a minus 5. This sign has changed, note, because minus sign is taken out common. So now we have the same brackets in both the terms, but here there is a squared, so you can consider this as two different brackets of 2a minus b. So we'll take out only one bracket common and the other bracket still remains in a separate bracket. So 2a minus b out common. So what is left? In the first term, what is left? Again 2a minus b is left because there were two brackets. And here what is left? Minus 5 is left. So this is the final answer. Now in the 15th sum, we'll open the bracket first so that we get 4 terms. And now out of these 4 terms, let's group the first 2 terms and the third and the fourth terms separately. Out of the first 2 terms, take out y common. So what is left is the other y minus a. Here, take out minus b common. So what is left is y minus, so again the sign has changed, a. The brackets are same, so take them out common and what is left is y minus b in the other bracket. So that's factorization. Now in the 17th sum, there are 5 terms together. So how do we group that now? Well, I can see some formula. I can see that if I take the first, second and the third and the 5th terms together, it becomes a formula x squared plus y squared plus 2xy is actually x plus y the whole squared, which is similar to the remaining terms. So I can now take x plus y out common. So what is left? Well, out of this, if you take x plus y common, another x plus y still remains because it is a squared. So write that x plus y. And here what is left? When nothing is left, that means 1 is left. So write 1. Don't forget the 1 out here. The 17th sum, mark it as IMP. Now the 19th sum has many terms. I see some similarities here. X minus 3y here, 3y minus x. I can just flip it by changing the sign outside. And even here I can take out 5 common to get x minus 3y inside. So let's do that. So here I just flipped it to make it x minus 3y so that the outside sign changes, because minus x has become plus x and 3y has become minus 3y. To change the signs, I have to change the outside sign as well. I did this because then this bracket will be same as this bracket. And even here, 5 is taken out common, so I get the same bracket. So I can take the bracket out common and whatever is left is another bracket. Here, what is left? M is left. And one more bracket is left because there was a square out here. Next, minus n is left here. And here plus 5 is left. Next, just open the bracket. Can you do anything else? Can I take out something common? Cancellations? Nothing. So this is the final answer. Now in exercise 5b, let's cancel a few easy sums. Cancel the first sum, second sum, and 18.1 to reduce your homework. Now let's start with the third sum. The third sum is not in the usual format. So what I have done is I have first arranged it in the usual format with minus 3a squared written first and the constant term plus 1 written at the end. It's not necessary to do so, but that's my style of solving this sum. Now in splitting the middle term, there are always 3 terms and it's a quadratic equation, as you can see. The middle term is minus 2a. This has to be split into 2 terms so that we get 4 terms, and then we can remove out common and do grouping. But when we split the middle term, we have to make sure that the product of the 2 numbers is same as the product of the coefficients of the first term and the constant term. So here minus 3 into 1 is minus 3. So what are the possible products of minus 3? Well, in this case there is only one possibility, 3 into 1. Now we have to be careful about the signs. We should give minus sign to 3 and plus sign to 1, because the product will give us minus 3. But the addition of these two will give us minus 2, which is what we wanted. So now we have split minus 2 into minus 3 and a. So minus 2a became minus 3a plus 1. If you add them, again you'll get back your minus 2a. But why not something like 2 minus 4? Even 2 minus 4 will give me minus 2. Well, as I said, the product of these two numbers, here there's a 1, should be equal to the constant term multiplied by the coefficient in the beginning, if there is any. So the only possibility here is minus 3 and 1. As we do more sums, you will get the hang of it. Now that we have 4 terms, now it's easy. Take out something common in the first 2 terms and something common in the next 2 terms. Here nothing is common, so take out 1 as common. The brackets are same, take it out common. What is left is minus 3 and plus 1. Of course, I wrote it like this. Next we have the fifth sum, that is 6a squared minus a minus 15. So here again I have to split the middle term, which is minus 1. But I have to split it in such a way that the addition gives me minus 1, but the multiplication of the two numbers should give me 6 into 15, which comes up to 90. So once you are an expert in this, you can do it mentally, but in the meanwhile you'll have to do a lot of rough work. 90, first I wrote all the prime factors, 2, 3, 3, 5, and now I'm checking out the various possibilities here. 2 multiplied by 45 will give me 90, 3 multiplied by 30, 5 multiplied by 18, 5 into 2, 10 multiplied by 9, 3 into 2, 6 multiplied by 15, and also 90 into 1, of course. So these are the various possibilities which will give me 90 on multiplication. But the addition of the two numbers should give me minus 1. So which possibility satisfies that condition? I see there is only one candidate, 10 and 9. But what about the signs? How about minus 10 and plus 9? The product will give me minus 90. That's what I wanted. And the addition will give me minus 1. That's what I wanted. So this is the right combination. So minus 10 plus 9 is giving me minus 1. And minus 10 into 9 is giving me minus 90. So this satisfies the condition. So this splitting is correct. Now I got 4 terms. Now take out 2a common here and take out 3 common here. The brackets are same, brackets are common, and the remaining things in another bracket. That's your answer. That's how you factorize a quadratic equation. I mean a quadratic expression. It's not an equation, because if it was equal to 0, then we call it an equation. But since there is no equal to 0 here, we can't call it an equation, we call it an expression. Now the seventh sum doesn't look like a quadratic equation, a quadratic expression, but on further inspection, it's actually like the third sum. Because when you open the brackets, you get a quadratic expression. And then split the middle term, minus 2a will become minus 3a and plus 1a. And the product is minus 3 as desired. Now take out 3a common here, and here take 1 common. You get the same brackets. So finally 2 brackets. Next, in the ninth sum again, if we open the brackets, we get a quadratic equation. So first I have rearranged it. So I want minus 7a squared first. I'm sorry, I keep saying quadratic equation, but it's an expression or equation. Now splitting the middle term, this minus 4 has to be split such that the product of the two numbers should be equal to minus 7 into 3, minus 21. Now there's no need to do any prime factorization, because there are only two prime factors, 7 and 3. So this is the only possibility, and the signs have to be minus 7 and plus 3, because minus 7 and plus 3 will give you minus 4, and minus 7 into plus 3 will give you minus 21. So we got our 4 terms. Now the common terms out, a plus 1 in bracket, 3 out, a plus 1 in bracket, and finally you have 2 brackets. That is the factors. They are called the factors of this quadratic expression. Now the 11th sum is IMP. What we'll do here is, first of all, I see that there is 1 bracket here, and if I take 2 common, I get the same kind of bracket here as well. But I can't take it out common yet, because in this term there is no a plus b bracket. Instead, let me substitute a plus b as x or any other variable, so that this looks like a quadratic expression. And this time, let me not rearrange the terms. Let me show you that it can be solved even if I don't shift minus 3x squared in front and shift plus 1 behind. Still, I can solve normally. So minus 2 has to be split into minus 3 and plus 1, of course, because minus 3 into 1 will give me the minus 3 product. Now take 1 out common here, because nothing else was. And here x is common. I get the same brackets. That's good. Now I can take the bracket out common and the remainder in another bracket. But the sum is not over yet. We have to resubstitute x as a plus b, because that was an assumption we had made earlier. And on resubstitution, now open the brackets. Be careful about the signs here. This will become minus because there was a minus outside. And this is the final answer. Now the 13th sum is strange because it has 5 terms. But if you look closely, what you can do is, the first 3 terms are a quadratic expression. So let's group them together. And the next 2 terms, keep it separately. And in fact, I can remove a common. So I get x plus 2. Now, if only I can get x plus 2 from this. It's a quadratic expression. So let's split the middle term 3x into 2x and 1x. Because the product 2 into 1 is 2. There's 1 out here. Now, in the first 2 terms again, take out x common. And in the next 2 terms, take out 1 common. And here we go. We got the same bracket which we wanted, x plus 2. Take it out common, x plus 1 in another bracket, and this term is just copied in the next step. So now out of these 2 terms, I got the same bracket common. So take it out common, and what is remaining here? X plus 1 is remaining. So just copy that, and what's remaining here? Plus a is remaining. So write that. So that's the final answer. Now the 15th sum is a beautiful sum. It's an IMP sum. 5 minus the multiplication of 2 brackets. Now there's no way we can open the brackets and solve it easily, so we'll have to use some other idea. Now I can see that there is a 3a square and 2a here, as well as 3a square and 2a here. Only the signs are different in between. So what I'll do first is I will take the minus sign out common. So in brackets what is left is 3a squared minus 2a. So now the brackets are same. And let's assume that to be x. So this complicated expression is now converted into something simpler and manageable, 5 minus x, 6 minus x. When you open the brackets, you get a quadratic expression, and we know how to solve them. Now here I'm going to rearrange it into the proper order, that is x squared minus 6x plus 5. Split the middle term 6x into 5x and 1. Or rather minus 5x and minus 1, because minus 5 minus 1 is minus 6 and minus 5 into minus 1 is plus 5. So the conditions are satisfied, the splitting is correct. Now I got 4 terms, so do the grouping, remove x common here and minus 1 common here. Keep in mind that the sign changes here. The brackets are same, so take it out common and what is left is here. But that's only the first part of the sum. Remember, we have to resubstitute as well, because x is actually equal to 3a squared minus 2a. So we need to mention these reasons. So now I got 2 brackets, but each of them is a quadratic expression. So perhaps we can further split the middle term in each case. Now here 3 into 5 is 15. So how can I split minus 2 such that the product gives me 15 and the addition gives me minus 2? It seems that it should be, how about 5 and 3, or minus 5 and plus 3? Because minus 5 plus 3 will give me minus 2, and minus 5 into 3 gives me minus 15, which is the product of 3 into minus 5 minus 15. So this is the correct splitting. Similarly here, minus 2 is minus 3 plus 1. So after splitting, we get 4 terms in each bracket. And now the usual method. Here take out a common, here 1 is common, the brackets are same. Even here 3a is common and here 1 is common, the brackets are same. So here take out 3a minus 5 separately, what is left is a plus 1. And here a minus 1, the bracket out common, and what is left is 3a plus 1. So finally we have 4 brackets. That means the sum is factorized. In the 16th sum, I see fractions. To get rid of the denominator, let's multiply the whole expression by 35 and divide by 35. Something like this. So here, multiplied by 35 and divide by 35. So effectively we are actually not changing anything, which obviously is not even allowed. So the benefit of doing this is that when you multiply each term by 35, the denominator goes away. But this division by 35, you can write it separately as 1 upon 35. If you can't visualize it like this, let me tell you an easier method then. How about just take out 1 upon 35 common. So 1 upon 35 out of the bracket, what is left is 1. 1 upon 35 out, so 12a is left. Here in fact I'll have to introduce a 35a squared, because only if I open the brackets, then what is 1 upon 35 into 35a squared? 35 cancelled. I will get 1 out here. So effectively this is what I'm going to do. Into 35 into 35 into 35, and the whole thing divided by 35. That's what I've done. Multiply by 35 as well as divide by 35. Why? So this 1 upon 35 will stay outside till the end. We can't do anything about it. But at least this way now, 35 gone, this gone, and this will be introduced as a coefficient. So at least the denominators are gone from this quadratic expression. So this 1 upon 35, let it be out. So this quadratic expression is now a usual sum. Split 12a into two terms, 7a and 5a. Take out 1 common here, take out 5a common here. So I got two brackets here, and that 1 upon 35, as I said, remains as it is. This is the final answer. Now in the 18th question, they have asked for each trinomial, which is a quadratic expression, find whether it is factorizable or not. That means, can we do the splitting the middle term method or not? So there is a formula which we can use here. First of all, in such sums, always compare the given expression with ax squared plus bx plus c. Now on comparing, when you see that a is equal to 2, b is equal to 2 and c is equal to minus 75. So we have to write those values and then use this formula. Now what is the origin of this? That you need not know right now, but it is very useful even in quadratic equations, which you'll study in future. Just substitute the values of b, a and c in this expression rather and get some answer. If this value of b square minus 4ac is a perfect square, that means the given expression could be factorized. But if it is not, if it ain't a perfect square, then the given expression ain't factorizable. Yeah, I use a z instead of s. Well, it depends on whether you're using American English or British English. Next, in Roman number 5, that is 18.5, first we have to open the brackets so that we get a quadratic expression. Now compare it with the standard form. So a is equal to 2, b is equal to minus 1 and c is equal to minus 1. Next, find the value of b square minus 4ac, which comes up to be 9. You see minus 1 squared. A negative number squared is always positive, and minus minus becomes positive. So 9 is a perfect square. Therefore, the given expression is factorizable. Next, 19.2. Mark it as IMP. This is a very unique type of sum because there is a root 2 involved here. So the basic logic is the same. We'll have to multiply the coefficient of the first term with this last constant, and the product should be factorized, and the middle term should be split in such a way that the two terms produced on multiplication gives us that product. So it's splitting the middle term method as usual, but with a twist. First of all, when I multiply the coefficient of the first term with the constant term, what do I get? 7 into 4 is 28, fine. But what is this root 2 into root 2? Well, that's 2, which we have studied in indices. So the multiplication is 56, which is a natural number. Now let's factorize it. I get the prime factors. Now I have to split this middle term minus 10 into two terms such that the product is 56. What combinations can we see? I can see 8 and 7, but that won't give me 10. Then I can see 14 and 4. Yeah, that could work. So I split minus 10 into minus 14 and plus 4. Let's check. Minus 14 plus 4 is giving me minus 10. Yes. And minus 14 into 4 will give me minus 56. Yes. This has to be minus 56, of course. So this is the correct splitting. And now we just have to take out common. So in the first two terms, what is common? I see 7x is common, so I got the bracket. And in these two terms, 4 is common, so I got the bracket. But the catch is the brackets are not same. How will I solve further unless the brackets are same? So what I'll do here is I would like to take out something more common. I see there is a root 2 here. And this 2 is actually nothing but root 2 into root 2. 2 is root 2 into root 2. So if I take out a root 2 common out, what is left here? X is left here, and here minus root 2 is left, which is good because now the brackets will be same. So take out the bracket out common and the remaining terms in another bracket. So that's your final answer. In the 20th sum, if this is the area, then we simply have to factorize it to get length into breadth, because area of rectangle is length into breadth. So let's just factorize this. First of all, 12 into 25 gives me 300. So I need to split minus 35 into two numbers such that their product is 300. Now there are various possibilities to give me 300. 12 into 25 as seen here. Then also we have 30 into 10, 5 into 60, 15 into 20, and so on. So there may be multiple possibilities, but the only condition satisfying pair is 15 into 20 because they will give me 35. So I'm writing minus 35 as minus 20 and minus 15. Because when you add them, I get minus 35, and when you multiply them, I get 300. And then take out 4x common here, 5 common here. The brackets are same, take it out common, and the other bracket as well. So one of them is a length and the other is a breadth. That's your final answer.